Hello everyone, my name's Dr. Paul Rose and this presentation is going to tackle some key skills that are required of the postgraduate researcher when they're completing an MSc project. We're going to look at scientific writing and critical analysis, how we write in an objective and relevant manner, and how we review, critique and synthesize information from the scientific literature. These are really important skills that you must develop if you are to be credible, open and valid in your outputs as a scientist. Firstly, I'm going to cover the idea of scientific writing and how this differs from writing that you may read in a newspaper or a fiction book or other printed text. Scientific writing is very technical. It's technical because it's subject specific and it is designed to communicate information to other scientists and researchers. Scientific writing is very fluent, it's concise and to the point. It's very specific to the area of science that has been investigated. It doesn't make sweeping statements and therefore it is objective and unbiased. It is very important that all information or argument presented in a scientific paper is evidenced and is therefore credible. Scientific writing can be said to have three key purposes: to communicate information with other scientists, which are the primary audience of that piece of work, to present this information to other scientists in a concise and precise manner, avoiding superfluous information or tangents that aren't relevant to the scope or aim of the research, and to set the information presented in the piece of scientific writing in the context of other published works, i.e. to use evidence from the published literature to explain and support the ideas and arguments presented in the scientific text. It's really important to remember that science must be, and always has been, cumulative. This means it's based on precedent, works that have come before yours that allow you to support your aims, ideas, and your research question in a valid and ethical manner. It's beautifully summed up by this famous quote by Sir Isaac Newton: "If I have seen further, it is by standing on the shoulders of giants." He's giving credit for all of the other scientists that did experiments and conducted theories before his that allowed him to show that gravity existed. This means that in your work, you must acknowledge where the information you present or have used comes from. You must cite accordingly and use quality evidence to explain your key points. Never assume things might be common sense to the reader. Always use a reference, always cite appropriately, and always acknowledge the work of others. Even if your research area is novel, other people will have been investigating similar questions in related fields. Use their knowledge accordingly. Make sure you acknowledge where your information has come from and try to add your next part to this cumulative gathering of information by explaining what you have found out and acknowledging past precedent that has allowed you to become the scientist and do the research that you're doing today. So what things must you do to write in a scientific manner? Firstly, and most importantly, you must cite all of the source material that you have read and used for your work, and you must remember to build on precedent. Regular use of referencing is really important. It's not appropriate just to cite at the end of every paragraph, for example. You must cite regularly and fluently as you go, whenever you use a piece of published information that's not your own, the information that you have found out yourself in your text. You must avoid superfluous information that talks around the subject rather than addressing it directly. Yes, something might be interesting, but does it support your aims or research question? If it doesn't give direct support to what you have researched, then leave it out. Please remember to use professional and technical language suitable for your audience. Don't write in a journalistic style. Don't use colloquialisms or turns of phrase that you might use with your friends. Be accurate, be objective, and be unbiased. Any forms of argument you use in your work must be supported by citations. Always remember to define and describe key terminology. Just because you're writing for other scientists doesn't mean they're going to have all of the subject knowledge that you do about your research area. So always define key terms, always explain nomenclature, and make sure your work is accessible. For example, if you're talking about behavioural ecology and you use the terms that are relative to that field that describe animal behaviour, make sure the reader is aware of what they mean. This way, more people will use your work, it will have more impact, and more people will know about the importance of your results. Let's now have a look at some other aspects of scientific writing that are really important to how you create your MSc Research Project. These are critical evaluation, critical analysis, critical review, and the synthesis of novelty that you create from the information that you read, as well as your own findings from your research. Critical evaluation, analysis, and review are how you extend the information that you're reading and how you make it relevant to your own ideas and observations. It's important that you go beyond description and discussion as a postgraduate student, and you're building more synthesis, more novelty into your arguments, and you're extending the information that you have taken in and you're applying it to what you have found, showing the reader why it's important. If you're confused or unsure about the word critical, this doesn't mean to be negative. Critical means to take an objective and unbiased view. You're thinking about the pros and cons, about the useful parts of the research, and about the limitations of the research. Critical analysis or critical evaluation is not for you to list all the things that you think are wrong with a piece of research. You shouldn't overtly criticize other people's science once it has been published. But you should review and evaluate in a professional manner the positive and negative aspects of research, methodological improvements or methodological challenges, consideration of statistical analysis, the relevance of the study population, the relevance of the methods used. All of these things that allow you to develop a full and complete assessment of the quality of the research that you are reading. Developing your skills as an academic writer is something that's built into each year of your undergraduate degree and is further extended when you do postgraduate study. First year undergraduates are expected to do description, choose relevant examples and explain why they matter. Second year undergraduates are expected to discuss, looking at that content, showing the reader its important points and put it into context of other academic papers. Third year undergraduates should be evaluating, explaining the pros and cons, the challenges, the limitations, the positive aspects of the research and how it supports their own work. As a postgraduate researcher, you should do all of these things, but extend them even further, doing the critical evaluation, critical analysis, and critical review that I showed you on the previous slide. You should also be synthesizing new information from your own research and from the literature. Yes, there might be areas of an MSc Research Project that use description, your methods and results, for example. And yes, you might discuss and explain important seminal papers in your introduction, but the basis of your discussion should be critique and synthesis of novelty. So try and avoid description and really build in the critical evaluation of the literature and your findings as you go through writing up your research project. Let's look at how we move away from description. As I previously mentioned, description is fine for the methods or the results sections, where you're simply stating what you did or what you found out. In fact, the reader doesn't expect any evaluation in the methods or the results because they're simply there to state facts. Description of scientific information in other areas of your report is less helpful because the evidence needs to be extended and put into context. Simply describing the papers that you have found doesn't allow your own credentials or abilities as a scientist to shine through. You must show the reader your own understanding of the information that's presented in the published literature. Why does it matter? Are the arguments credible? Are they useful to you? Do they help you support or refute your hypotheses? Can you compare or contrast papers and build a bank of information from the literature that really shows how you're critiquing your own work and synthesizing any new information or ideas? I'm now going to go over some key pointers that allow you to build from description through to critical evaluation and synthesis. So description can be termed what, where, who, or when. What is the article about? Where is the problem being explored or investigated? Who is involved and who are the interested parties in the research? And when did the research happen? So this is all very basic. It's a simple explanation of what the article contains and who has done it. It doesn't really extend the relevance of the article to your own work. It simply sets the scene for what information is presented in a paper that you have read. The next stage of academic writing is to turn description into discussion. And the discussion is how, why, and what if. How has the research been conducted? How have the methods been used? How have the aims been written, for example? The why looks at why was the problem explored or investigated in the first place? Why was this a relevant or credible piece of research to implement? And the what if considers any noise or variables around the research question or methods that might have implications for their findings. What if things had been done differently? What if different animals had been used? What if a different setting had been the choice for the research output? These things allow you to discuss the results that are stated within the paper itself. Finally, we come to the evaluation, which can be summarized as so what and what next. The so what looks at the meaning, significance, implications, and the arguments presented. Are they valid and convincing? Are they unbiased and objective? The what next considers the success of the experiment or piece of research and how is it built into research extension. What's transferable from the research? Is it applicable to other industries or areas of science? This is particularly important in this day and age because multidisciplinary research is that which is seen as most impactful. Have the researchers met their aims and objectives, and where should it go next? Remember that I mentioned that the best science is cumulative. The most ethical and valid science is continually building forwards. Does the reader explain their research extensions that shows how others could extend their research question to keep finding out new information? So when you evaluate, think about building all of these ideas, all of these new ways of extending research, how are you considering what has been done, how research has been presented, to look at the arguments around its significance and validity, so you can really see all areas of the research, all challenges faced, and all opportunities that are available. You can find many resources online that provide examples of descriptive writing versus evaluative writing. But here are just a couple of statements for you. Description could be when you state a result that you have read in a paper. Critical evaluation would identify and consider the relevance and significance of this result and its meaning to your work and to other published pieces. Description would be when you reproduce the details of a method. Evaluation would be when you consider the appropriateness and relevance of the experimental design, the challenges and limitations or opportunities of using that method to consider which approach may work best. And finally, description could be where you simply state the aim of a paper that you have read. Critical evaluation would be reading the aims of many papers within your research area to compare and contrast how they support that aim to see which may be the best or most opportune way of meeting that aim by conducting a piece of scientific research. Once you've done your evaluation, you can build in thinking about adding something new. So within your discussion of your own research, you have your pool of literature that you've read, you've critiqued it, you've analysed it, you've evaluated, you've looked at the pros and cons, the limitations and the opportunities, the areas of research extension. Now you can synthesise new ideas or arguments from what you have found out and from what you've read. So synthesis is where you create a new argument, idea or concept based on your own interpretation of the available material and your consideration and evaluation of your own results and findings. You must remember to do the same objective and unbiased critique of your own science as how you're doing of published science. What are your challenges? What are your limitations? What are your opportunities and research extensions? Your synthesis of the literature allows for alignment of your arguments with those that are similar, so what you have read that supports your findings, as well as what is contrasting. What have you found out that's contradictory to other pieces of research? And can you propose new ideas or new ways of doing things? So long as you are objective and based on evidence, you can suggest reasons why you may have found things that are different, that could change accepted thinking. Synthesis occurs via the review of numerous sources and pieces of available evidence. You don't synthesize something new from the reading of one scientific paper. This is why, once you have done your critical evaluation of the pool of literature that's relevant to your research project, and you have your results, and you know their meaning, and you know your limitations and research extensions, then you can think about synthesizing something new, interesting, or applicable from the literature and from your own research. So you try and build this into the discussion section of your report, where you're bringing everything together, showing the reader how you've critiqued the available research, how you've critiqued your own work, and bringing this together before you present your final conclusions right at the end of your piece of research. Please remember the importance of reading. I know I have said this in previous video presentations, but it is so important to how you develop as a scientist, a researcher, and an academic. Those are the key transferable skills from doing an MSc. Not necessarily the specific subject, but about becoming the quality scientist. The more you read, the more you develop your academic skills, the more you will develop your scientific writing styles. The more you will develop your grasp of academic language and how to use it. And therefore, you will hone your skills in critiquing, reviewing, evaluating, and synthesizing the meaning from the papers that you have read and that you are using. Reading around the subject is not something that us academics tell you to do, so we don't have to write lectures. It's the most important skill that you will develop and use to make you an unbiased and credible scientist. If you understand the literature, you will become part of that cumulative process because you can fit your own research into the cycle of the evolution of the literature. Remember, the literature changes all of the time, so you must keep abreast of the most recent and most important papers, whilst understanding those seminal papers that have gone before. So to do the critical evaluation and the synthesis, read, 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 and read again. I hope this presentation has been useful to your development of scientific writing skills. Thank you very much.